Hi, this is Phil from Simply Rhino, and in this video I'm going to be taking a quick look at a new mobile workstation from PNY. As a background to this, I was at a recent trade show with PNY demonstrating Rhino on this machine and was given the opportunity to borrow it for a few days to do some testing. Happily, this coincided with the launch of V-Ray 3.6 for Rhino version 6, and hence this video. So I'm going to take a quick look at the hardware and then show how Rhino version 6 takes full advantage of GPU acceleration, and finally I'm going to take a look at V-Ray 3.6 for Rhino version 6 and show how GPU and hybrid rendering can significantly boost your rendering times. So let's start off by taking a look at the hardware. This is the PNY Prevail Pro P4000 mobile workstation, and thanks to PNY Europe for making this available. Fairly obviously, this isn't an inexpensive laptop, but it does represent good value for the very high specification offered. The processor is an Intel i7-7700HQ with 4 cores and 8 logical processors. This runs at 2.8 GHz but has a speed boost of up to 3.8 GHz. There's plenty of storage with both a 512 GB solid state drive and a 2 TB hard disk included. The screen is a UHD 4K 15.6 inch display with a resolution of 3840 by 1160 pixels. The highlight of this machine though is the GPU. The Prevail Pro features an NVIDIA Quadro P4000 graphics card with 8 GB of GPU memory and 1792 CUDA cores. It's VR ready and powers up to 4 displays. The P4000 is the top of the range NVIDIA Quadro mobile GPU, and this laptop is the only machine currently to offer this GPU. Now, in terms of size, this is a very compact and reasonably lightweight machine, especially considering the high specification. Measurements are 380mm wide by 248mm in depth, and if we close up the machine, you'll see that it's very thin, around about 18mm. In terms of connectivity, on this side we have 2 full-size USB 3.1 ports, 2 USB Type-C ports, 2 mini display ports, 1 HDMI port, and of course the power cable port. On the other side we have the RJ45 Ethernet port, a memory card reader, another full-size USB 3.1 port, and the microphone and headphone ports. There's ventilation slots all the way along the back of the machine and the top half of the left-hand side. It's a reasonably lightweight machine at around 2.2 kilograms, and if we just open up the machine, you'll see that there's a full numeric keypad which is backlit, and of course the usual trackpad and associated buttons. So we're now inside Rhino 6 on the Prevail Pro, and as you probably already know from our new features in Rhino v6 videos, Rhino v6 now supports GPU acceleration much more fully compared to version 5. So one of the reasons that a machine like this would be useful for Rhino is of course if you are working with very large models. Here we have the same 1.4 GB test model that I used in the new features video. This has 10 million polygons in the render mesh, and you can see that it's very easy to navigate around the model. If I now switch to version 5 on the same machine, you'll see the movement and rotation of the model is much more compromised. Now let's just have a look at a very quick speed test. Here's the model in version 5, and I'm going to run the test max speed command that calculates the time that Rhino takes to rotate the model 100 times. Here you can see it's very slow, so I'll skip to the end to get to the result. So this completes in 79.78 seconds. If I now switch to version 6 and run the same test, we'll see that this completes in 4.08 seconds. So we're getting nearly a 20 times increase in speed with version 6 over version 5. So this is a pretty compelling reason to upgrade if you haven't done so already. Rhino users who do a lot of rendering in V-Ray for Rhino may also find the Prevail Pro extremely useful. V-Ray now has very good GPU and hybrid rendering solutions that can take full advantage of the P4000 graphics card as featured in this machine. Here I'm going to take a look at rendering out this scene in V-Ray for Rhino. The Rhino model is 260 megabytes and there are just under 3 million polygons in the Rhino render mesh. Although the model looks relatively simple, it's actually based on fully detailed production data and as such contains much complexity. I'd like to thank Carl at Safe Innovations Limited for the use of the file in this video. So now let's take a look at V-Ray for Rhino 3.6 running inside Rhino 6. This is the file as previously described, and I want to take a look at how fast this renders on CPU compared to GPU. I'm going to open up the V-Ray Asset Editor, and if we look at the settings that are being used here, I'm starting at the default settings. If I go into the command line, all of the V-Ray commands now have a V-Ray rather than a viz prefix, and there is now a command called V-Ray change default scene. The preset default for V-Ray is that of a product design studio, but there is also a default for architectural visualization. This is the setting that we have enabled at the moment, and this changes a couple of settings, most notably turning on the sun and sky system using the Rhino document sun by default. In this scene we have the sunlight plus 3 rectangular lights to illuminate the pod interior. There are some emissive materials for the lights inside the base, and all of the materials are based on straightforward library materials. From the default settings I've made a couple of changes. I've turned on the denoiser and left this at its default settings, and also turned on the aerial perspective setting in volumetric environment. I'm using this to soften the image slightly by thickening up the environment and making it slightly hazy. In terms of the default settings in V-Ray 3.6, these are now set to use brute force for primary rays and light cache for secondaries. Progressive rendering is turned on by default. These settings are the same for both the product design or architectural defaults, and these now do a pretty good job in most instances, rather than using the irradiance map calculation that was very often the preferred route in V-Ray 2. You'll see there is a setting here to switch between CPU and GPU engine, and I'll start off by selecting the CPU engine. In terms of the render output size, I've set this to be a fairly large image at 3051 by 1692 pixels. So let's hit the render button and see how this progresses. At the bottom of the frame buffer you can see some feedback. V-Ray first compiles the geometry and then builds the light cache. And I'll now skip to the end of the render process. So we're coming to the end of the render passes, and then we'll see the denoiser pass. This is a separate pass that we can adjust without having to re-render, and you can see that we have a render time of 13 minutes 5 seconds, and that's about what we would expect using 8 reasonably fast processors. Let's now switch over to the GPU engine and select the Quadro P4000 and render out the same scene. If we look at the feedback in the bottom of the frame buffer window, we'll see the data being transferred to the CUDA cores. What I've seen from some initial investigations is that with very small scenes there is often not much benefit from using the GPU engine, but as soon as we start working with large scenes and add complexity, then there can be a really significant advantage in using the GPU engine. I'm now going to skip to the end of the rendering process. So we're just about going through the denoising process, and now you can see that we have a render time of 4 minutes 16 seconds. So in this example we are 3 times faster using the GPU engine over the CPU engine. If we go back again to Rhino and the V-Ray Asset Editor, you'll see that there is also an option called C++ CPU in the GPU setting, and this is how we set hybrid rendering. The advantage of hybrid rendering is that if you have a good GPU solution, you can combine CPU to the GPU and again improve render times. It's important to understand that this is a GPU solution with additional help from the CPU rather than the other way round. So let's take a look at how hybrid rendering works in this particular instance. From the frame buffer, I'll hit the render button, and then once again I'll skip to near the end of the rendering process. This time the render time has decreased to 3 minutes 40 seconds. So you can see there is a significant improvement in using hybrid rendering over CPU rendering. Before I finish, there is one other thing I'd like to take a quick look at. And if we just zoom into the image here and I just choose to show the RGB color channel, then you'll see the image without the denoising effect. If you're familiar with V-Ray, then you'll know that the brute force calculation has always been very accurate and gives really nice color bleed. But historically, the two main disadvantages have been speed and noise. The brute force calculation in V-Ray is now very fast, and the Denoiser does a really good job of smoothing out that typical brute force noise. One of the nice things about this approach is that the Denoiser effect can be adjusted without having to re-render. So if you want to retain a little bit of noise to give your image a nice analog or film type appearance, then it's very easy to fine-tune this. So that's about all I wanted to cover in this video. Please feel free to leave any comments below, and if you found this video useful, please hit the like button. To keep up with the latest news on Rhino and V-Ray, please subscribe to this channel. Thanks very much for watching, and I hope to see you again in the next video.